already designing software, right? And I really can't memorize to save my life. So, you know, that's just one example. I also am an engineering program dropout, just for the record. So I dropped out of that one as well. But I bring up this particular example because it's an example where it was really, it wasn't that I didn't like the degree. I didn't like this. I didn't like that the information in this class was irrelevant. And I didn't like the assessment strategy of the class. I knew there was no way I could ever pass this class because there was no way I could ever memorize 2,000 pieces of information for a test, right? How many of you, if you would tell me in the chat, how many of you was something in that quitting of something related to an assessment or an assessment strategy? Not just a personality. I see Amy shaking her head. There are lots of reasons we quit things. Anyone find it was related to assessment? Now, we are, for the most part, good at school, right? All of us have gotten through probably at least a master's degree. You heard Mike list my degrees. It's not that I don't know how to school. I know how to school, right? I just didn't like this particular type of assessment strategy in this school. And I think that we might actually be the exceptions to this because we did successfully get through school. That was actually the first time in my life it was really an assessment that stopped me from something. Now, a poor assessment strategy in a class can block students from entire career fields. If you listen to the stories at parties, you know how you exchange, like, what do you do for a living? And then you tell them you teach math, and then they tell you that it was their least favorite class in school and how much they hate math and all of their sob stories about teachers. I see lots of nods here. Though that disconnect with math, it blocks students from entire fields. Students drop out of nursing because they don't like trigonometry, or they drop out of engineering because they don't like pre-calculus. And like, there's all this lost human potential because a math class stops them. And I want us to think a lot today about what is it in these math classes that's actually stopping students? Is it the math, or is it the way we structure the courses? Are we, without meaning to, weeding students out of majors where they could have great contributions to the world? A good assessment strategy can actually do the opposite. A good assessment strategy can bring a student into a field instead of keeping them out. So that's what we want to try to do. I want to start with the elephant in the room, which is exams. We are math folks. We are used to both taking exams. I can remember taking exams in times tables. Probably all of you have pleasant memories of, maybe not all of you, but most of you have pleasant memories of like doing times tables exams and being really good at it and things like this. So all the way back down to like kindergarten, first grade, second grade, we probably have good memories of our time taking exams around math. But I don't think our students all do that. And in this pandemic, exams kind of became a pain point for everybody, not just in math, but in STEM in general, because we're used to giving proctored exams. And that's how we, for the most part, authenticate whether a student knows the material. We give them an exam, we proctor it, we control the situation, and that's how we've done it for a long time. So I'm going to ask you another question here. You don't have a choice. You are a student that just cheated on the exam. I want to know why you did it. And again, don't press enter till I say so, because we want to wait to see all the answers at once. So you're a student that cheated on the exam. Why did you do it? These are great excuses. I hope you're taking a second to scroll through this. Pure memorization, had to get a good grade, didn't think I could pass without cheating, couldn't figure it out on my own, didn't feel like studying, felt desperate, scared to be wrong, better grade, didn't have enough time to study, fear of failing, lack of confidence. The learner didn't make the teacher didn't make the learning fun enough instead of taking responsibility, didn't study, felt stressed out. So lots of common reasons here, right? All we can do as teachers is lower these reasons. We will never, ever stop 100% of students from cheating on an exam. And I think we should actually just stop trying. There's actually a disconnect between designing a course to stop cheating and designing a course to optimize learning. These things are actually incompatible. I was just at a conference this week where one of the papers showed us that if you give immediate feedback on exams to students, there's a group of students called harvesters that might go, there's a single harvester that will go through and mine those answers to give them to groups of students to answer the test with, right? So giving immediate feedback actually feeds that cheating strategy. But then they studied what happens if you don't give immediate feedback and you just, like, say, have one exam that's high stakes at a particular time. And in that case, what the students do is wait till the last minute, cram, and take the exam, which is like the exact opposite of what we know should be happening, right? We know we want repeated engagement. We know that students actually benefit from immediate feedback when they're learning, right? And you actually can't, you can either design for learning or you can design for cheating. And so I would suggest that we design for learning and lower the other factors, these excuses that you just made, lower those as much as possible so that it's not something that students actually want to do. So there's lots of factors in the literature that lead to academic dishonesty. I just thought I would list them here for you because these are the things we can actually target. There are factors like peer pressure, performance anxiety, excuse making, inability to manage the demands of student life, situations that encourage academic dishonesty, self-justification habits, unfamiliarity with what it is, and lack of understanding about consequences. So what I'd like to do is actually talk about how we can impact and lower every one of these through our own course design practices. And then these also have the side benefit that we improve equity in our classes by doing them. We improve the variety of learners who are able to be successful in the classes by doing these things. So a couple of very quick strategies, just as a review, in case you never saw the original webinars last year. Provide a formula sheet to students. You lower a lot of factors that lead to cheating if you just provide a formula sheet. If you're desperate, you can mail one to students who don't have printers. They're fairly easy to drop in the mail. But most students, there's lots of ways to do this. Anyways, give them a formula sheet. Now, I often hear from math teachers, but the engineering students, right? So I actually went and looked at these engineering exams that we hear so much about, how engineering students can't use calculators, engineering students can't use formula sheets. And I just want you to know that the NCEES exam does allow calculators, just for one thing, in case you weren't aware. And on top of that, they get 14 pages of mathematical formulas to take these tests. Nobody's making them memorize all this stuff for the engineering exams. It's just the engineering teachers doing it, not the exams. So don't use the exams as an excuse to not give them a formula sheet. They will have all these formulas when they take those exams. The important thing is that they know how to use the formulas, when to apply them, what to do with them, right? That's actually where it's at. It's not, can you find a formula? And the problem, of course, is that anybody with a phone can find a formula in like 30 seconds. So this stuff here, don't make students cheat just because they could have Googled something in reality. So just give them a formula sheet. Another quick and easy fix for this is just having them handwrite an academic dishonesty statement, or hand type it, or just do it so they can't just copy and paste it from someplace. It's very important they actually write it to internalize it. And so I just have a very simple one. I did not receive help on this exam from anyone other than my instructor. I did not help any other student with this exam. It's very important that you have both statements in there, because then you're stopping academic dishonesty from both sides, both from the person who will be pressured to help and the person who is asking for the help, right? And so you cut it off on both sides by just having a simple statement. Another suggestion is to make sure that you give an essay exam or some component of your exam as an essay exam. It gives students more of a chance to express themselves, for you to see what they're thinking. And many people are just not very good at taking multiple choice exams. They read, I'm one of them. I read too much into all the questions. I can think of a zillion edge cases that aren't listed in every answer. And then I start, churning on that. And then I pick something and it's often the wrong thing. So giving students some other chance to really write about this, or to make their own notes with your multiple choice exam that says, like, I would like to just explain why I chose this on this question because I'm confused about it, right? Giving them some way to engage besides just answering A, B, C, D, or having algorithmic graded things. I actually give open notebook exams at this point. I've found that it helps the students who have poor English language background, like they're learning English as their second language. It takes them longer to read things. It helps them to be able to go back and look at how things are written and match those up. It really depends on what you put on your exams, whether this strategy will work for you or not. But you can write questions that are equally difficult to answer whether they have notes or not, and that's what I recommend doing. If and then you don't have to worry so much about the resources they have because they have what's in their notebook. But I want to get past exams because this is not actually where we create equity, although there are a few things here, like I said, I think we can do to help. There are actually deeper issues here past exams, and there are a lot of other ways to assess that we should consider because they do help students from a variety of backgrounds to improve. So we can actually control 6 factors in assessment that will help us to lower the cheating factors and raise the equity, the success in our classes. And those are alignment, transparency, authenticity, variety, agency, and creativity. So we're going to go through these kind of 2 at a time here. I want to start with alignment and transparency. Now, before we get into alignment, we have to talk about the real problem that we have in our math classes. And it's not just math classes, but boy, math classes seem to have this problem. And that is that over time, our curriculum experiences curriculum drift and curriculum bloat. So let me explain what those 2 things are. Curriculum drift is when we add new things that need to be learned in a discipline. And you'd think there wouldn't be a ton of this in mathematics, but there is actually. Like 100 years ago, we had no curriculum around calculators, right? That's all been added in the last 100 years. So first there was just curriculum with scientific calculators, then curriculum with graphing calculators. And then it turns out when you can suddenly visualize things very easily, we can look at math from a whole different approach. We can look at it from a graphical approach in a way that we couldn't have 100 years ago, right? So we have actually been adding curriculum. On top of that, we also have curriculum bloat. And curriculum bloat is when you guys are all familiar with how, we typically do something like a textbook adoption or an OER adoption. And what often happens is that a couple of schools or one school will say, we won't adopt this book unless you add examples of this, unless you add this particular problem type, unless you add a section to this chapter that covers this. Well, over time, that just means that the books get bigger and bigger and bigger, right? And yet we still kind of design our classes like, oh, chapter 3. We used to teach chapter 3. We better still teach chapter 3. Never mind the fact that chapter 3 got bigger with every edition of the book. We still just teach that chapter. And we're handing a lot of these classes off to adjuncts. And those adjuncts don't have any real guidance about what to leave out in individual sections, like teach these 2 things, but not these 2 things in this section of this chapter, right? And so between the drift and the bloat, you end up with this course that is way bigger than it was originally taught with. It was, pre-calculus was a 4-credit course 50 years ago, and it's still a 4-credit course, but now it has more stuff in it than it used to. Well, that means something has to go. We can't do it all. We need to focus on the things that are actually important now for the students we teach today in the world that we live in today. So the way we do this is we do alignment in the course, and there's 2 types of alignment we'll do. The first is that we align the learning objectives to the course objectives. And so this is where things get real for us. You have to look at your course objectives and see if your course objectives are actually real. They can't just be a list of topics. They need to actually be skills that you want a student to have. So these are some examples of course competencies or course objectives. You know, they're things like, you know, for graphs and relationships, interpret the key features of graphs and relate graphs to the mathematical equations to wisely use math in other contexts. That is a skill students learn. It is not a topic that they learn. It is a skill they learn, and they learn it throughout the entire class, right? This is what a course objective should look like. So another example, apply technology to enhance mathematical interpretation and determine reasonability of solutions, since real world problems rarely involve integers. There's actually slightly better wording of this one, but I don't have it on this slide. So you can take issue with the integers if you'd like, but just know I've revised that one slightly to deal with that. And what I mean by that is when we do things like regression, you almost never get any kind of integers on a regressed data, right? And in the real world, we do tend to do things with data modeling, not with whole numbers. Even in factory situations and things like that, we're using averages of numbers, and these just don't tend to be integers. So anyway, so your course objective is real. Take a look at your course objectives. And if you just have a list of topics like students will understand parabolas, students will understand polynomials, students will understand rational functions, that's not course objectives. Those are just topics. So you need to start with a list of real objectives. Once you have a real objective, then you go through the learning objectives and you say, is this learning objective actually relevant to any course objective that I have? Declutter the course. So if you find that you're teaching the distance between the midpoint and the radius, or the distance formula, for example, on a circle or something like that in your class, ask yourself, go back to this list of objectives and say, which of these objectives does that learning objective meet? And if it doesn't meet any of those objectives, you've got two choices. You're either missing an objective, a course objective, or this learning objective doesn't actually need to be here. Maybe it belongs in some other course. Maybe it's something that you can teach them if it ever comes up in a problem, right? But maybe it's not something you actually have to focus on. And so I think that this is one of the things you have to do for alignment. Now, with that said, many of us are given a list of course objectives, and we have very little and learning objectives, and we have very little control over what they are until the next time it comes up for review. So there's another solution for this that helps with alignment. And skip that one. This is something I call the ESIL lens, and ESIL stands for Existence, Supported, Independent, and Lifetime. And this allows us to take a look at a particular learning objective and decide how deeply we are going to teach and assess it. That way we can leave it in the course if we have no choice, but it is actually your choice, your academic freedom to decide what you are going to, exactly how you're going to do that, right? It's your choice usually whether you're going to test the heck out of it or just have the students demonstrate it to you. And so let's take a look at just an example here. Solve a quadratic equation. I don't have to explain to you what a quadratic equation is, which is lovely. So solve a quadratic equation, we would actually break it into 4 objectives. This is actually too broad of an objective to apply the ESIL lens to. And so, you know, we might say that we have actually 4 things to teach. Solve a quadratic equation using factoring, solve it by completing the square, solve it using the quadratic formula, solve it using technology. 4 different objectives. They're all solved, by the way, which is the Bloom level 3, in case you're, you know, thinking about that at all. I'm going to just skip a very long discussion about this and say that in my world, solving a equation by factoring actually rarely works in the real world because you rarely have integer coefficients in the real world. And so, and if you understand cardinality at all and the probability of the factors actually being integers, it works almost 0% of the time. Now, solving an equation by completing the square or the quadratic formula, they both work. They both work 100% of the time, but they are kind of redundant to each other. If you know one, you can actually solve a quadratic equation all the time, right? And of these two, it is probably easier to teach our students to do the quadratic formula if they must memorize something and must be able to use it without a formula sheet or a calculator. Heaven help them. And so I find that it's easier to teach them the quadratic formula. And interestingly enough, in China, they actually teach them completing the square as the standard. But then the last one, solving a quadratic equation using technology, I think this one's actually fairly important because they can do it on their phone. And I can teach them how to do it in under a minute. And if they ever encounter it in physics or economics or chemistry, they will at least be able to do it, which I would rather that they can do, rather than just throwing up their hands and saying, I have no idea what to do. My math teacher never taught me this, which tends to be what they say, annoyingly enough, even though you know you taught it to them, right? So I'd rather they have some strategy than no strategy. So I think that one's fairly important. And here's how this translates then to ESIL. Solving with factoring, I do this one supported. I show them what factoring is so that if they encounter it other places, they'll have it. But they just demonstrate that they can do that supported, because really, if they ever have to do factoring, they can go find a tutorial, they can relearn it, they can, there's lots of resources for that, and it's just not practical. Completing the square, I make sure they've seen it once and they know there is a strategy called completing the square. Solving with the quadratic formula, I want them to be able to do that independently. And then solving using technology, I want them to be able to do that forever. Right? I want to be able to solve any equation using technology forever, so that no matter what they encounter, they can do it. So what that means practically, most of the learning strategy is the same, although for things that are independent and lifetime, you do more repetition, right? But the assessment strategy is very different. For an existence level, you don't assess it. For a supported level, you use a low stakes assessment, something like a homework assignment or a group assignment or an open notes quiz. For independent, you want multiple types of assessments and probably at least one high stakes assessment, meaning that you're going to do something that's kind of time blocked or resource blocked or something like that. And then for a lifetime, you want to have it keep coming up. You want to have it come up in multiple courses if you can. You want to have it come up on a final or cumulatively on a bunch of different tests, so they just can't forget how to do it. It should just keep coming back. So that's what ESIL can do for you. You can take the learning objectives you have that you're required to teach, and you can just change the gradation of them a little bit. Get used to the idea that not 100% of your learning objectives need to be tested, because they really, really don't. We don't live in a world from 100 years ago where your only access to information was what you had in your head or the couple of books you might be lucky enough to own. We're not in that world anymore. We need to start making adjustments to it. What this looks like practically, if you go ahead and do this kind of alignment, I have the learning objectives in the center column right here. I'm just going to point to them here. So my learning objectives are right here, right? I have my CLO. I know which CLO these go with, and I know what level of ESIL they're at. And notice that when I have a supported here, I'm not putting them on the exam. It's just a problem set, right? And when I have something like a lifetime, this might also be, oh, I cut off, there's a final exam column here, I cut off. It will actually show up on both a midterm and a final here. I'll just put an F over here for a final exam. So anytime I have this lifetime, I would want to see it also on something like a final exam, a final project, something like that. I can also align the learning activities to it then. I can make sure that things that require more depth have more learning activities to them, right? And so I can make sure that every learning objective has both learning and assessment, and I can use a variety of assessment for that. Okay, so the other thing you want to do on top of alignment is you want to also make sure the students can see transparency. A lot of that angst that they have around tests and grades has to do with not really understanding how they're going to be graded or not thinking it's fair. that not thinking it's fair, that's a real stickler, you know, in people's heads when they start thinking about whether they're going to cheat or not in a class. And so one of the things I like to do is, so I have all of my learning objectives and I actually put them in problem sets. I say like, okay, we're now going to look at these learning objectives. These are the things, so I'm going to point right here. These are the things that I want you to demonstrate in this next problem or set of problems. I am looking for these things. Can you determine an appropriate timescale for the application problem? Can you find the linear regression model? Can you describe the line of best fit? Can you predict future values, right? That's what I'm looking for. They're going to see these learning objectives attached to the videos they watch or the activities we do in our remote class or our face-to-face class. They're going to see these learning objectives tied to their assignments. They're going to see them on study sheets for exams, right? As a matter of fact, when I get to the study sheets for exams here, this is a study sheet for an exam. This is for the final exam, actually. I actually do it by the competency. I organize it by the competency instead of, or the CLO, instead of by the learning objectives. And so I just list out the 7 competencies for the class, give them examples of things that would fall in there. And notice that when you're looking at graphs and relationships, you've got linear, trig, quadratic, exponential. There's lots of different kinds of things they could have in there, right? And so that helps them to connect all the ideas back together. If you have a plan and you can demonstrate you're following the plan and that there are no surprises, that everything comes from that plan, it does lower the anxiety for students. They know exactly where to find things, they know exactly how to study. And I think that helps us a lot. It helps us to help them. It also helps us to help their tutors. It helps us to help their roommates who are helping them. You know, if it's clear what they're supposed to be, it helps them to Google to find like tutorials and other help resources if they have some idea what it is that they're supposed to be looking for. Okay, so the next thing I want to talk about is authenticity. Sometimes I think that what we teach them is this kind of, actually, I'm pretty sure that what we teach them is this kind of second grade drawing of mathematics and how it's used. It's not the Picasso version or the photograph of how it's used. It's like this, we make tons of assumptions, we simplify the problems, you know, to make them doable. I mean, I'm sure you can all recall some really, I don't know why I pick on factoring now, but I just do, sorry. You could all recall some word problem in a book where they solve by factoring, right? But there's nothing about it that's actually real world. It's like Mary was 5 years older than John 3 years ago. So how old are they now? And somehow it's a quadratic equation and you solve it, right? That's not authentic, right? So, when we do these traditional math assessments, you know, a lot of times this is how students think about it, math, right? They sit at a table, they take a test, hopefully they don't think about this like, hopefully we do more interesting things than this now, but this is how many people think about, many parents, many students think about math assessment. And the problem with that is that when we use math in the workplace, it looks very, very different. There are computers, there are other people, there are resources, right? When we use math in the workplace, it is not this hermetically sealed environment. It's an environment that involves computers and all of these other folks. And so we really need to think about that in our assessment. We need to give them more authentic assessment. We can give them exams too, but should it really be the thing that blocks a student from going into these careers? Because once they're there, they have those resources. And I also just want to point out that it's very rare that we see data patterns that are nice in the world. They usually have hiccups in them, or they have some periodicity to them. This is for example, routing requests for Apple's what is it called? Apple Maps, right? So, you know, the people who are requesting walking directions, driving directions, and public transportation directions, right? And it's very cyclical over a week. Like it increases and decreases as we go through weeks and weekends, right? this is the kind of data they encounter once they're in a job. It's not a smooth, perfect curve. It's not a sine curve. It's not a linear curve. It's like a combination of curves. And if we don't teach them how to deal with some of those things, then they do hit their other classes and they hit the workplace, and it's like they've never taken a math class in their life. We never taught them how to do this. We only taught them how to do things on beautiful graphs with near perfect behavior. And we need to start getting a little bit more real and authentic. And even if we don't do the full mathematical workup on something like this, we need to be able to talk about it with them. They need to be able to describe it, describe what they're seeing and why that's happening, and be curious about why the graph has all these peaks and falls on it, and why some trends are increasing at roughly the same rate and some are not, right? And be able to postulate about that. On top of authenticity, we can also talk about the other types of assessments we can use for math courses, so the variety that we can have. So I actually want to ask you a question again. What other types of assessments do you use or could you imagine using in math courses besides, we'll call them paper exams, but they could be either paper exams or online exams. What else is there besides exams? What else can we do? Tell me all of your great ideas or the things you are already doing. All right, you guys hit enter anyways. That's fine. Hit enter if you're following directions. Great, lots of things. Journals, group quizzes, interviews, projects, think, pair, shares, video presentations, Desmos, tell me a story problems, that's nice. Oral exams, Kahoot, group projects, discussion posts, projects using real data, Excel projects, nice idea, group exercises. So we've got a lot of strategies here. I'm going to share a couple that with just a little bit of detail. Many of these have blog posts or entire presentations on just one of these topics. So if that's something that you would like to see, I asked Mike if he would kind of keep an eye on the chat for like, oh, can we get a link to this one? And I'll try to share those afterwards and he'll send them out to you. So I'm gonna just share a few of these that you can do to get away from kind of a paper exam or a digital exam. Video demos, oral exams, projects, problem sets, labs, simulations, discussion. So let's just talk about a few of these. So first, video demos is one that I've used successfully in a bunch of different classes. It's, for example, how I might have students demonstrate that they understand factoring, because this would be a supported way to do it. They could practice it as many times as they want and then record themselves demonstrating the difference between 3 factoring problems or something like that. I make a rubric for these things. They record their videos usually on their phones. This one is recorded on a phone. It's sitting on a table and looking down. They use a piece of paper or a whiteboard or whatever they've got handy. And then I just go through and watch it. I actually, when I pull up their videos, I record myself watching their video so I can just comment out loud, and then I send it back with their rubric filled out. And so it's a good way to assess, can they explain it to you, right? And it gives them plenty of opportunity to try and do it multiple times until they think they have a good one and then send it to you, right? So it's a way to help students who are maybe good at talking through things, but not so good at answering questions on a test. Oral exams is another technique that I've used in classes. You definitely, oh, it looks like my text is a little bit cut off there, sorry. It's definitely not something you want to do all the time. It's not something you want to do for full length tests. You want to schedule these for like 15-minute sessions. There is an entire, this is something I have some posts on and some resources on, so I can send more information, but it would take me about an hour to go through exactly how this works. Just know that it is possible, and there's some great resources on this. I have a little primer on oral exams that I can send to you after this. So then you can kind of look at what the rubrics look like, how you actually practically carry it out. You do need to have rubrics to do this. And I actually only do this twice in the semester, with the caveat that if I find that your oral exam score varies wildly from your open notes test scores, then I reserve the right to give you oral exams for the rest of the semester. Right? And that actually does quite a bit for making sure that your students are who they say they are. It's often quite a surprise to them to do this, but it is also important that you practice if you're going to do this. Okay, next one. Structured discussions. I think I did a presentation at IMACC a couple years ago on structured discussions, and I have slide decks and a couple of presentations I can send you to on this one. The idea here is that rather than having these kind of one question discussions, you have a very structured discussion where one person does one thing and then other people come along and add to the information. So one person might post a problem, the next person solves the problem, the third person checks the problem, something like that. So with structured discussions, you can still get at some interaction and some assessment of what students know, but you're not doing it in a high stakes way, and you're giving people some time to think about their responses. Doing this kind of variety of assessment, you can see here, there's essay questions, discussions, video responses, and exams. That serves a student with a variety of experience, not just the students who are good at taking exams. And just think for a second about what kinds of students would actually be good at taking exams. Would it be students who have parents that enroll them for test prep and sit down with them and help them study for exams? Or would it be the students who are on their own for studying and can't afford test prep classes? We test students in math in a way that specifically targets certain populations of students who are going to already be good at taking tests. We have to do other things if we want those other students to succeed. And we need to. So the last one I want to talk about is agency and creativity. So agency, for example, I know that Kathy Almy is here, and we both talk a lot about these non-Googleable kinds of questions. There's a big difference between asking a question that can be answered super simply with simply a Google or photo math or something like that, and a question that requires more thought and more agency from the students. So these are both questions about, there's supposed to be an actual function showing on the screen. Not sure what's happening there, but imagine you have a quadratic function in both cases, okay? So both of them are asking, would actually get at, does the student know the vertex? Because it's likely that given a quadratic function, one of the properties would be the vertex. But the second phrasing of it allows the student to show you they know all the vocabulary about quadratic functions or parabolas, in addition to all the properties, where the first question just asks about one specific thing. And heaven help them if that's the one thing the student doesn't know, but they could identify the intercepts and they could identify the axis of symmetry. And if vertex is the one thing they don't remember the word, what that word means, but they knew everything else, they've just gotten a 0 on something. Whereas if you ask it in the second way, you've given them agency to tell you at least what they do know, right? And this is what it looks like. Oh, there's the function. This is what it looks like when a student does answer a question like this. And look at the vocabulary they know. They know it opens down. They know what vertex means. They know what axis of symmetry means. They know what X and Y intercepts are, and the zeros. Look at that. They know what the domain is, the range is. They know how to give an interval of increasing and decreasing. You've asked them to show you what they do know instead of trying to poke at what they don't know. Do you see the difference? Plus, it gives you great joy to see they know all these things. It's much more pleasant to grade things where they're getting it mostly right than where they crash and burn on one thing. Here's another example for a calculus class. You could ask them to find the limit algebraically and give them one problem to do. Or you could give them 3 or 4 problems and then tell them that they need to find the limit on these problems, and they can do it either graphically, numerically, or algebraically but they must use each method at least once. Then they choose. And isn't that better? Isn't it better for them to choose which problem would be a good one to do graphically, and which problem would be a good one to do algebraically, and which one would be good to do numerically? That actually shows you a lot more about what their technique is and their thinking is. And it gave them agency. And here's what that looks like. In some cases, they did it every way, and in some cases, only one. But that also means they knew how to check their answers, right? They knew how to verify by multiple methods that they were correct. So I think that that's also a really exciting result.
Hey, Maria, we probably should be wrapping up here.
Yep. I think I have okay, so we'll skip elaborations. There's a blog post about this one. And let me just jump to, for some reason I thought I had an hour, so sorry about that. Okay, so if we can do these things, then if we can increase these factors, these alignment, transparency, authenticity, variety, agency, and creativity, then we also, as a bonus, lower these things that cause anxiety and cause students to cheat, right? And I think that, you know, instead of then weeding students out of our system, we're giving all of the students we have an equal chance to thrive, an equal chance for success. And that's why we need to actually focus on our assessment and our assessment strategies for increasing equity. So I'll just leave it at that with some questions. And I don't know how much time we have for questions, Mike. You can cut me off.
We have a couple. We had one earlier. Someone asked, would it be a good idea to have students make up their own formula sheets?
I actually prefer to give them the formula sheet, and here's why. There's two schools of thought on this. One school of thought is they have to find all the formulas and write them down. My worry about that is if they just either, for the students who are short on time, we often find that they don't do it. And that's not necessarily they won't necessarily learn more by writing the formulas down. Often it's just copying from screen to paper, right? And so then you are hurting the students who have the busiest lives, the ones who probably have kids to take care of and multiple classes and a full-time job. You're hurting them when you ask them to make the formula sheet. I prefer giving them the formula sheet and letting them get used to using it all semester and letting them see how, like I give them the one formula sheet at the beginning, and then they just learn how to use more and more sections of it as they go. That helps them to kind of recognize which formula to use, and they don't tend to try to cram a lot of examples on it. But then everybody starts the exam with an equal playing field. They all have the formulas, right? And I prefer that. I think I don't want to hurt the students who just have less time than others to do this work. Or ask them, I mean, it's again an opportunity for academic dishonesty, right? Like if you don't have time and somebody else does, you say, hey, can I have a copy of your sheet? Like, is that academic dishonesty or not? Like, just eliminate it from the category altogether. Were there other questions, Michael?
I haven't seen any.
Okay.
So far, and keep in mind, everyone, Maria will send me the links to those alternative assessments, and then I will email that out to everyone, so you actually have them. Yeah. Okay. If there aren't any other questions, I want to thank Maria so much. Everyone can put up their little applause, little emoji
jazz
thing.
hands.
Yeah, the jazz hands.